What? Yeah, sieving. Check. So these are various methods that we can use to separate mixtures. Those that we have available. I think we're left with magnetic separation.
Yes.
Magnetic separation. So we are going to explain each of the statements and then the type of methods. So on the board are quite a number of. We have distillation, filtration, evaporation, sublimation, the use of the chromatography, sieving, winnowing, decantation, and magnetic separation. Need of what? Combining at least 3 or 2 of the method to separate a particular mixture. You understand? So as an example, a mixture like salt, sand, and water. You understand? This one cannot be separated with only one method. So several methods will be adopted to separate the mixture successfully. Do you understand? So I will go into explanation to the methods. Then we see what we have in front of us. That is something small we have to demonstrate some of the methods that we can use to separate mixtures. So distillation. We are talking about the distillation first. 2 types. But before then, the word distillation means that separating what? 2 miscible liquids. Separating 2 what? Miscible liquids. And when we say miscible liquids, we mean petrol and kerosene. They are miscible, right? Water and alcohol, they are miscible. Do you understand? So such mixtures can be separated using what? Distillation. Do you understand? Mix them together. And then I ask you, listen, identify the alcohol out of the water. Can you do that with your eye? Good. So you cannot do that. And so in that case, we will boil the 2 mixtures together. Do you understand? And then one of them will boil faster. So the one that will boil faster will evaporate. Do you understand? And then as it evaporates, there will be a certain device called a condenser. It would condense the evaporated substance into liquid form, and then we have collected that one. Then whatever that will remain in the container would also be the other component. Do you understand? So we use their boiling point difference. When we say boiling point difference, different materials boils at different temperatures. Do you understand? Remember metals and non-metals. We say that metals have what? High boiling point. Do you understand? Metals have what? High boiling point. Right now, and I'm heating what? Non-metal. Which one is going to boil or get heated first? The what? The non-metal. Do you understand? The non-metal. Because the non-metal, with less heat or temperature, they can get what? Melt. Do you understand? As compared to metals, which it will take a longer time before a metal can melt. Do you understand? Even though metals, they will melt, but it will take a very longer time. So the one that will take a longer time before it to get heated is what we say it have what? High boiling point. And if you don't take much time, with a little heat you get melted, then you have what? Low boiling point. So compare water and alcohol. Which one of them have a high boiling point?
Alcohol.
No. It's water. Alcohol boils at
78
degrees Celsius. Do you understand? So if we are boiling these substances together at 78 degrees Celsius, we are going to have alcohol being what? Boiled. Okay, alcohol is going to be what? Boiled. And then water will then start boiling at what temperature? 100
degrees Celsius.
So you see the difference between them. Assuming they were all boiling at the same place at the same time, let's say water boiling at 100 and then alcohol also boiling at 100, then it would have been difficult to use a distillation to separate them. You understand? But this is the case. Fortunately, by nature, the 2 substances have difference in what? Boiling point. Do you understand? So alcohol boils at what? 78 degrees Celsius. And then water boils at what? So if I'm separating alcohol and water, which one will be separated first? God bless. Water will be separated first? No. Remember that 78 will come before what? 100. So at 78, we'll start separating what? Alcohol. You understand? And then we'll separate water what? Last. So they have a temperature thermometer fixed into the setup. When you are done, we'll look at the practical aspect of it. There's a thermometer fixed into the setup. So the thermometer will read the temperature of what? The substances. Do you understand? So at 78 degrees Celsius, they will start collecting what? Alcohol. So at 78, water will not boil. If you don't boil, you don't what? Evaporate. Do you understand?
Yes.
After boiling, evaporation what follows. Do you understand? Okay, so that is distillation. Then filtration. Yes, you can separate it. So they need what? Heat source. You understand? Remember, you cannot get evaporation without boiling. In your household, your parents cook, right? Have you cooked before? No. So when you cook, when you put water, even water on fire, and the water boils, and when the water boils, you can see water vapor coming out of it. Do you understand? You tomorrow, today when you go, go and observe, at least get to the kitchen and then observe how cooking is done. I know you have nothing to do with cooking. I know you go and cook, but go and observe how cooking is done. When you are cooking and you open the lid and you will see the vapor coming out. Okay, so that is how it happens. There's no evaporation without what? Boiling. Do you understand? Good. Understand? And then the other one, the boiling point difference is very what? Large or huge. Do you understand? Now the one that the boiling point difference is high. And let's say between alcohol and water, 100 and 178. What's the difference? What's the difference between 178? 22 degrees. That's the difference between what? 100 and then 78. Do you understand? So 22 is the difference. Then there's a difference between especially petrol and kerosene. And their boiling point is so small. Between petrol and kerosene, their boiling point is so small, it could be like 5. Do you understand? In that case, we cannot use a certain distillation. We have to use another form of distillation. And so that leads us to two types of what? Distillation. We have the simple and what? Fractional distillation. The simple one uses the temperature with what? A very huge temperature difference, like the water and what? Alcohol. Do you understand? So water and alcohol temperature difference is what? High as compared to petrol and what? Diesel. Do you understand? So if your temperature difference is very small, then it will require you to use what? Fractional distillation. Do we get that? So an example of mixture that are separated with fractional distillation is crude oil. Remember, crude oil has components of what? Diesel, petrol, LPG, kerosene, etc. Right? So all those are what? The components of crude oil, and they have a very close temperature range. Do you understand? And so due to the close temperature range, they are only separated using what? Fractional distillation. So there are two types of what? Distillation. Simple and what? Fractional. Alright, now let's come to filtration and then we do move straight. With filtration, it is a method used to separate what? Insoluble solid. Insoluble small solid from what? Liquid. Do you understand? An example is insoluble solid, a solid that does not dissolve completely in water. Do you understand? That is insoluble solid. So if we put sugar, sugar is solid, right?
Yes.
So if I put sugar, I think we even have, okay, Gary is here and then sugar. Ajubi's Gary, the remaining is here. Alright. So I'm going to take a small amount of sugar, okay? And then I'm using this one to just demonstrate the difference between soluble solid and what? Insoluble solid. Good. So I've taken small amount of what? Sugar, okay? And I've placed it into what? Our that is not beaker, it's an improvised beaker. The real beakers are here. So I'm adding what? Water. And then let's see if we can still see the sugar in it. Okay? And come, Deborah, come. Deborah. Alright, so stir it and then let it mix completely. Stir. So you can stir by either shaking it or by using your hand to kind of, but in scientific experiments, we don't mostly use our hands in a direct contact with the mixture. So we have what we call the stirring rod, which we don't have it here right now. So we can improvise maybe using this marker to kind of stir. Do you understand? So what is she doing? Stirring. And so stirring is one of the ways that can help you to increase the level or the rate at which solids dissolve in what? Solvent. Do you understand? Okay, I think we can see that there's no sugar particles remain in the mixture. Can we all see that? Yes. There's no sugar particles remain. This means that sugar is a soluble what? Solid. A soluble what? Solid. Very good. Same way, let's try it with a different what? Solid. And see that if it's also going to dissolve. Now we have Gary here. We have Gary here. So let's take a small amount of it also. And this time around, Marvin, come here. Marvin, you have to do magic because we want to see our Gary mixing with the water, right? Yes. And as a matter of fact, if you look at the particle size of the Gary and the sugar, it's not that there's no much difference, right? So the Gary should be able to mix completely, right? Yes. But let's see what's going to happen if it's going to mix completely. Alright, so you also stir it and then let's see if it's going to work. So he is stirring the mixture of Gary and what? Water. And so we are expecting, say, if the Gary will mix completely. If not, then the Gary become what? Insoluble solid. Insoluble what? Solid. Do you understand? Alright. I think it's the same time she stirred, so let's wait and see. I think we can still see the Gary particles, right? And in this case, we can conclude that the Gary particles is not what? Soluble. And if it's not soluble, then it is what? Insoluble. So that is a solid insoluble. And that is what we are talking about here. That in filtration, we separate what? Insoluble what? Solid. From what? Liquid. But then there are two types. It's either the insoluble solids are very large. You understand? But with this one, you could see that the insoluble solid is very small, right? Yes. Let's compare this one to gravels. You know gravels, right? Or small stones. The particle size is big, right? So for that one, we can use what? Decantation. Do you understand? So decantation and filtration is very similar. Do you get it? But the difference is that in filtration, we use what? Funnel. We use what? Funnel. But in decantation, we don't use what? Funnel. And then also in decantation, the particle size is what? Large. And then in filtration, the particle size of the solid is what? Small. Do you get the difference? Yes. Very good. So now we are going to demonstrate filtration. And so join us here, Lisbeth. We are going to demonstrate filtration. Now, what do we need in filtration? We need our what? We need what? Our funnel. Now, not just the funnel. We also need either what? Filter paper. Now, the filter paper can also be in the form of cotton. And so we've placed our cotton wool inside the what? The funnel. Who can tell me what the cotton wool is going to do? What purpose is this cotton wool going to serve? Yes, let me see by hands if you can tell me. Oh, okay. So the cotton wool has a narrow hole which the Gary particles cannot what? Pass through it. So hadn't it be only the funnel, we could see that there's a hole in the funnel, right? Yeah. Which in the case all the solid would have passed through it, right? And so that is why we need what? A filter paper. And then our what? Aside the filter paper, we need what? Either a beaker, but this one I have here is the what we call the volumetric flask. It's called what? Volumetric flask. And so we need that one as well. We can also use what? The funnel, the beaker. But with the beaker, you see the funnel is very long, so it's going to be very difficult to use this one. So the best appropriate to use here is our volumetric flask, or yes, our measuring cylinder. You can also call it a measuring cylinder. Do you understand? Good. So this is a setup of filtration. But in the laboratory, this setup must be left maybe hanging. Do you understand? So the funnel will be held by something else, which is called the retort stand. The retort sand. So there, hold it like this. Good. And then there will be something also holding the funnel like this. And that is the rectal sand in the scientific laboratory. You understand? You know, this is just an improvised setup. So we'll have the rectal stand and then the clamp, which is holding the funnel directly or firmly onto the setup. You understand? So that when the liquid is dropping, we can see it dropping. You understand? It's what? The mixture. And then whatever that we obtain here inside this beaker is called what? Filtrate. It's called what?
Filtrate.
You understand? So the product of filtration is called what? Filtrate. So today we are just demonstrating the filtration and then magnetic separation. Do you understand? So let's quickly go through with that. So Lisbeth, we have our setup here, and then we have our mixture of Gary and what? A mixture of Gary and what? Beautiful. So we want you to separate the Gary for us. We want to use the Gary for something else. One interesting thing about mixture is that whenever a mixture happens, it can be separated. Do you understand? So let's do that quickly. So pour it into the container. Pour everything at once. Okay, that's okay. So we can see that some of the Gary will remain here, and that is decantation. You understand? Decantation is when you are pouring the liquid away from the solid. You understand? And so that's what she did. But some of the solid also fell into the funnel, and so let's see if they would be able to pass through the funnel and then get into the the beaker or the measuring cylinder. Which sometimes you have to allow some time for it to go through the process. You understand? But we don't have much time, so we just look at what is happening here. Now, can we see any solid in this one?
No.
There's no solid substances in this one, right?
Yes.
Which means that the Gary has been successfully separated by our funnel and then the filter paper. And so when we take the filter paper, whatever that is left in the filter paper after filtration is called
Filtrate.
no. What is left in the filter paper after filtration is called residue. It's called residue. And what is left or what is obtained in the cylinder is what we call the what? Filtrate. Do you understand the filtration? And this is done in our house in several means. I mean, the preparation of what? Palm soup. You understand? After and then rice and water. Yes, we do that a lot. So it is very practical in our houses. You understand? And sometimes they use what we call the sieve, which is also like sieving. So sieving also looks similar to what? Filtration. You understand? All right, quickly. Let's look at magnetic separation. So the three of you can leave. Now, Marco join me here, Divine join us here, and then Odonko come. So with magnetic separation, listen, we need two substances. Okay, one of the substances must be what? Magnetic material, which in other words, it must be metal. Do you understand? Although not all metals are attracted by magnets. And then you must need your magnet, right? And so we have a magnet here with us here, and then we have a magnetic material called iron filings. Iron filings. And so we are going to mix the iron filings with sand. Iron filings with what? Sand. And then we'll see if we will be able to get the mixture back. Okay, so we have the sand here. We have sand here. We are going to add iron filing. Those of you who have not seen iron filings before, this is iron filing. So over here we show you the practical of it. It's not just telling you that there's something called iron filings. We are showing you iron filings. In the next week, we'll try and get you separating funnel and then other methods of separating what? Mixtures. So let's pick some iron filings here. Marvin, can you mix them together for us? Marco, mix them together. So that's how iron filing looks like. Okay, that's how iron filings look like. Use this one and then mix them together for us. We want it to mix completely with the sand. And let's see the magic of science here. So this is Big Apple Academy, right? And this is science class. So we are demonstrating how we can separate our iron filings from what? Sand. Now we can see the mixture completely. Yes, the mixture is formed. And then, if we are supposed to remove the iron filling by hand, will it be possible?
No!
Very good, because they are very, very small and very fine, and it's very difficult to remove this with the bare hands. And so, magnet is here to do the magic. So, Odonko, take it. This is what we are going to do. He is going to send the magnet close to the mixture. What is going to happen is that whatever magnetic material that is found inside the mixture will move towards the what? The magnet, leaving the non-magnetic material what? Behind. Do we understand that?
Yes.
Okay, so now let's demonstrate that. So send the magnet close to the mixture, okay? And then don't be scared of whatever is going to happen. Yes. Send it close slowly. Send it close slowly. Alright, don't too close. So let's see what is happening. What is happening? The iron filings are moving towards the what? The magnet. They are moving towards the magnet. This is very, very, very interesting. That is science. Do not doubt the power of what? Science. And it is being made possible by the help of our magnet here. Wow. He has done it perfect. Let's clap for him. Yes. Yes. And that is our iron filing taken away from the magnet. Taken away from the mixture of what? Iron filing and what? Sand. Now we can see a pure sand here. See? So if you have been sent to buy iron filings and mistakenly it fell into what? The sand. Do you go and tell your parent that your iron filings is spoiled?
No.
But instead you go and look for what? A magnet, and then try and separate the iron filings one by one. Right? Very good. So Diva, you're going to demonstrate it one more time and then we'll call it the end. So we can pour it back like this. When they move away from the magnetic substances, they lose their magnetic properties. See now they are not attaching each other, they are not attracted to each other again. Yes, so when they are taken away from their magnetic source, they loses their magnetic properties, and that is iron filing. Iron filing is made up of what? Ions, and iron is a metal that is attracted by what? Magnet. Very good. So this is very simple practical here, and this is magnetic what? Separation. Magnetic separation. Divine. Separate the mixture for us. We have the mixture again. We saw what Odonko did. So do the same thing for us. Let's get our magnets. Let's get our magnet, the iron filings back. Okay. All right. Let's clap for science. Very good. Very good. So that brings us to the end of the class today, and that is magnetic separation and what? Filtration. Next week we'll bring you more of these practicals, such as separating panel, and then decantation, and then the other methods. Don't worry, you get the opportunity to do so. Sit down and let Madam take her canteen. Let's sit down. So, hey, I need my iron filing back, please. My iron